Good afternoon, everyone. Hello, dear authors and invited guests. Welcome to Technical Session 4C. It is my great pleasure to welcome you to the 6th International Conference on ICT for Sustainable Development through Zoom on behalf of ICT4SD 2021 and Global Knowledge Research Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable times and making this conference more productive. We hope you will enjoy 2 days of the knowledgeable and interactive sessions. Just before we get started, I would like to introduce the session chair, Dr. Nilesh Modi, Professor and Director, School of Computer Science, Dr. Baba Sahib Ambedkar, Open University, Ahmedabad, India. Dr. Nilesh Modi, professor in India, he's having a rich experience of around 12 years in academics and IT industry. He is good at following fundamental and technical skills such as cybersecurity, data warehouse and data mining, Photoshop and others. Thank you for your presence, sir. Also, there's a special note for the presenters. You will be given 8 minutes for the presentation and 2 minutes for question and answers. So please kindly keep that in mind. We have parallel sessions going on, so do not extend the session. Yeah, thank you so much. So we'll start with the first presentation. Do we have Sridharan here? Sridharan, I've asked you to unmute yourself.
Yes, ma'am. Yes, ma'am.
Yeah, you will be presenting on ICT and administrative reforms, a literature review, right?
Yes.
Thank you. You can start sharing your screen. Yes, you can start sharing your screen.
Can you see that, please?
Yes, I can
Is it
see
visible? Yeah.
Yes, it's visible. Please start. Thank you.
Thank you. Good afternoon, everybody. My name is Sridharan. I'm a retired management consultant and a PhD scholar at this point in time. This paper is about ICT and administrative reforms, and we wanted to find out what the literatures say about it. And the context is administrative reform. So this will be the sequence of the presentation. There is an executive summary which summarizes the whole thing into a single slide. Introduction, objective of the study, context, research methodology, analysis, finding and conclusion, the normal style. The executive summary is this. Essentially, the study is intended to study the concepts that play out in ICT when ICT is being used in the context of administrative reform. So the methodology uses grounded theory for literature review. The data analysis is the technical papers on administrative reforms and ICT put together. And the study revealed that there were 21 dimensions which come into play when ICT is being used as a leverage. ICT is used for leveraging. ICT is leveraged for administrative reforms. And these 21 dimensions fall into something like 4 concepts. And 2 of the concepts are at a contextual level and 2 of the concepts are at a project level. So this is essentially the summary of what our study is. As an introduction, we'll say this: an administrative reform falls into the category of reforms, which are listed as economic reforms, social reforms, political reforms, legislative reforms, judicial reforms. But we are only interested in finding out what administrative reform or ICT when it is used in the context of administrative reforms. Administrative reforms can be defined as an artificial inducement of administrative transformation, or in other words, improving government operations through deliberate interventions. Now, when ICT is being used for this, what happens is the study. So the study of literature. So what we want to do is, what are the main themes which come out of this? This is the objective of the study. What are the main themes which comes out of the literature review? And what are the dimensions which fall under the themes. So essentially, that's what it is supposed to be. The context of ICT and administrative reform is in the past 20 years, ICT has played a major role in shaping the administrative reforms worldwide. And there have been multidisciplinary fields which have been emerging. But what we are interested in is when ICT is being leveraged for an administrative reforms, what are the things that we should be careful about and what are the contexts that we should keep in mind. That's the part of the study. Research methodology is the grounded theory where we try to find out what the concepts are and what the dimensions are. And what we do is we use the concept of open coding, Excel coding, and we use the concept of concept metrics, and we use the Scopus database to find out the literature. And the search criteria is administrative reforms, so all the spellings have been taken into consideration and where ICT comes into picture. So what we have done is administrative reforms these papers, we ensure that really deal with what can be termed as an administrative reform. So very small improvements have been taken out of the scope of the, so for example, a queue management improvement has been taken out of the scope. So when we search the database with that search criteria, initially we found 68 technical papers. When the duplicates were removed, it was reduced to 51. Then we reviewed the title and the abstract. It came to 48. Then we reviewed the full text and the same numbers were written, so we could not eliminate anything from there. Then we also found out from other sources an additional 5 papers. So the total papers which were reviewed is 53 papers. When we reviewed the 53 papers, the first and the foremost thing that we did was we ensure that all of these things deal with administrative reforms. What we did was we reviewed the papers and found out that the 37 papers dealt with national departments. So 37 papers dealt with the national departments, 10 papers dealt with provincial departments, or in India, we can call them as state departments, and the local governments are a single location where there were 6 of them. But these things were almost the 6 of them were at a pilot stage so that it could be treated as a part of an administrative reform procedure. So these are the subjects which were covered. So there's no point in going through all of this, but essentially this gave us the confidence that we are dealing with papers which deal with administrative reforms across departments. So it was large enough. The new channels which are being used for people to interact, decentralization, anti-corruption measures, influence of ICT on ICT strategy, all of these were the subjects covered in these papers. The coding process was, we started with the open coding, then went into the Excel coding, then we went into selective coding. While this was happening, parallelly, we also started recording what are the base concepts. Concept metrics essentially dealt with what are the,
but we have last 2 minutes. Let's conclude your
okay.
presentation.
Okay. So when we did this, essentially there were 6 concepts which emerged, and the 6 concepts were rationalized to 4 concepts. These are the 4 important concepts: ICT context, reform context, ICT use, and the factors which should be taken into consideration in this project. So in this, what we found out was the first 2, the ICT context and the reform context, were at the contextual level, and the ICT use and the factors used were at a project level. So when you analyze this, so these numbers only demonstrate, how the rationalization took place. And so this is the final finding. In the final finding, we found that there were 4 concepts which came into picture, and out of the 4 concepts, 2 were at a contextual level and 2 were at a project level. So this gave us a clear-cut indication saying that for a project of this nature to succeed, it is not enough that we do well at a project management level, but we also need to understand the context very well. And there were 2 important contexts which came into picture. One is the ICT context itself, that is, where is ICT going at this particular point in time? and the administrative reform. In the administrative reform, we found out that what is the context in which the administrative reform itself is being done. For example, is it globalization, or is it a change of governance mechanisms? These contexts have become very, very important. Now, these contexts, the 4 contexts, were further reduced or broken down into 21 dimensions, which are listed down here. In that context, what then happens is so the biggest problem that we face in such a study is this. ICT and public administrative reforms both are extremely complex areas, and these 2 complex areas, when they study together, it induces some sort of a limitation. That limitation is there in this study too. The most important finding is this: most of the projects do not meet their objectives because they fail to take the information and communication technology context, which is where the technology itself is going and where the public administration context itself is placed. Now, these 2 are very important because the administrative reforms per se are not short projects. To implement an ICT, public administrative reform, it normally takes anywhere between 5 to 7 years. So between the 5 to 7 years, the initial assumptions will have to be valid throughout, or the context will have to be always monitored. So that's the most important conclusion that we came to. And we also came to the conclusion that the ICT context and the public administrative context being ignored are the main reasons why the public administrative reforms trying to leverage ICT do not normally fructify the way it is initially conceived.
Thank
That's all,
you.
sir.
Thank you
very
so
much.
much. Thank you.
Thank
Sir,
you.
any questions, sir? Nilesh, sir?
No question from my side.
Okay. Thank you, sir. Thank you. Thank you, Sridharan.
Thank you
We'll
very
move
much.
on.
Thank you.
Yeah.
Thank
You
you.
can stop sharing your screen.
Thank
Okay, so we'll move on to the next presenter, Mitra. Mitra.
Yes, I am there.
Yeah, you will be presenting on COVID waste management using IoT, a smart framework, right?
Yeah.
Thank you. You can start with your presentation. Yes.
Okay. Is my
Yes.
screen visible?
Yes, it's visible.
So good afternoon, everyone. I am Mitra Tithide, Assistant Professor and Head, Department of Computer Science, Netaji Nagar Day College, Kolkata. And my co-author is Dr. Purnasha Chatterjee, Assistant Professor and Director, School of Mobile Computing and Communication, Jadavpur University, Kolkata. So today I am going to present our paper, COVID waste management using IoT, a smart framework. And this is the outline of my presentation today. So due to COVID-19 and lockdown, a lot of COVID wastes are getting generated from COVID infected persons who are at home isolation or at medical centers every day. And plastic products like masks, gloves, aprons, face shields, sanitizer bottles, etc. have played very significant roles to protect people from COVID-19, which creating pollution. So inefficiency of traditional waste management includes excessive human intervention that can spread virus at the community in a higher rate. Also, COVID waste are dumped with other waste for long time. Smart waste management can address these serious issues. So presently, most of the works discuss manual COVID waste management. We found only one work which focused on smart waste management on mainly post-pandemic scenario, but no smart infrastructure to handle present situation was proposed there. So in this paper, we are proposing an IoT-based smart framework for COVID waste management, which can mitigate the challenges of present situation. And we have also proposed 2 different types of smart waste bins for handling COVID medical waste and COVID household waste separately. And these 2 bins can be described as follows. First one is SCWB, that is Smart COVID Waste Bin, SCWB household, and that are to be deployed at residence of COVID patients who are at home isolation. And another one is SCWB Medical, to be deployed at COVID medical centers who are at hospitals, nursing homes, etc. And this is the proposed structure of SCWBH for households actually. And this contains some sensors like load sensor to detect waste weight, infrared sensor to detect waste level, gas sensor to detect poisonous gas emission inside the bin, flame sensor to detect fire inside the bin. And we have proposed to use LoRaWAN as the communication unit, as it is a wide range low power communication module which provides energy efficient communication for battery powered SCWBs. And we have proposed to use Arduino as a microcontroller. And this is the structure of our SCWB aim that will be used for medical purposes. I mean, that will be used at medical centers. This container actually have 6 sub-containers. The first one, green container, will contain the biodegradable waste. And I mean, all are COVID waste actually. So I'm not specifically mentioning COVID term here. And second one is yellow container, which will contain the contaminated waste. Third one is red container to contain the recyclable waste. Fourth is white container, which will store the metal objects or sharp objects actually. And fifth one is blue container to store the glassware materials. And the sixth one is the gray container. When user is unable to categorize the waste, he or she can opt for the gray container. Gray container allows automatic waste segregation. A conveyor belt, as shown in the figure, a conveyor belt is embedded there, and plastic, metal, and glass sensor will be attached in series to identify different waste types. And all the 6 containers are attached weight, level, gas, and flame sensors. And this SCWB aim can be operated by a mobile app through which authorized users can select specific waste types, and depending on the chosen type, lid of the appropriate container will be opened. And by this way, contactless lid opening can be done. And this is our proposed smart COVID waste management framework. As we can see in step 1, SCWB aim are deployed in COVID medical centers. In second one, tracking patient locations by mobile app who are at home isolations. With the help of COVID patient tracking app like Arogya Setu, etc., affected persons can send data to government, and this data is stored in cloud server. And third step is gathering patient location information remotely. And depending on patient density in a particular area, number of required bins can be estimated and deployed at the patient's resident who are at home isolation. This is shown in step 4. In step 5, gathering information about SCWB status. Actually, SCWB, that is the bins, send their COVID waste status to the cloud server of the remote municipality. And after some data analysis, different statistical information can be fetched, like SCWB filling rate in which areas and at what time of the day. Generally, the SCWBs are filling fast. Percentage of different types of waste in various locations. Number of emergency alerts like fire or gas emission inside the bin. All will be sent by the SCWBs per day. And based on this information, some strategic planning can be made for further decision making, like in which areas more or less number of SCWBs are to be deployed, in which areas cleaning is most frequently required, etc. And then once SCWB locations are and status are known, then by executing shortest path algorithm, an optimal route can be calculated, which can traverse all the SCWBs with minimum delay and less fuel consumption. And the route map is sent to the vehicles through the mobile app of the drivers. And in case of autonomous vehicles, route map is directly sent to the smart vehicles, avoiding human engagement. And the last one is waste collection. With GPS technology, drivers or autonomous vehicles can easily locate SCWB position, and waste are collected in a contactless way using robotic arms of the vehicles and are dumped in a separate area in dump yard. And so these are the advantages of our proposed framework. It is automatic as less human involvement required. It provides real-time operation like adverse situation where waste overflow, presence of gas or flame inside the bin is detected.
Ma'am, but you have last 2 minutes.
Yeah. I'm concluding. Okay, and this adverse situation can be immediately detected through sensors and reported to municipality in real time. So urgent actions can be taken. We have proposed to use 2 types of bins there. One is SCWB for household, another for medical centers. And our proposed framework actually utilizes resources very much. It provides less fuel consumption, minimum number of collection vehicles engaged, least human intervention, etc. And beans can be added and removed as per requirements without hampering the operation of the whole system, so it is scalable. And the proposed system can be easily integrated with the traditional manual system. So I have already told, we have presented a novel IoT-based smart framework for COVID waste management. Two types of beans have been proposed. The system is automated, provides real-time actions, and requires least human intervention. But there are some initial establishment cost for deploying the beans. And in future, we have a plan to develop prototypes of the proposed SWBs and implement them and test the whole framework in laboratory environment. And here are some references from where we got the idea about smart waste management and COVID waste management. So thank you. Thank you all for being there.
Thank you,
Whether
Michelle.
this proposed model, it has been implemented or it has been deployed, or it is just proposed?
No, sir, it is just proposed, and we have already told in the conclusion section, actually, we have a plan to implement all this in a laboratory.
Sure. Thank you.
Yeah.
Good
Thank you.
concept.
Moving forward, our next presenter is Bonani Paul, and her paper title is Internet of Things, 3-Layer Architecture, Security Issues, and Countermeasures. Bonani, are you there? I think you are muted. Hello?
Bonani,
Yeah. Am I audible? Am I audible?
you are audible, but can you please share your screen? I request if there is any technical issue, come back again. We'll start with the next presentation and then you can present after the next presenter. Yeah, Bonani? Is
Some
it
internet
okay?
issue. There is some internet issue here.
Yeah. Will you present now?
Yeah, I'm trying to do the needful.
Or else what I suggest is stop sharing and you can come back once the presenter is done. So till then, please solve your issue. Gatera is here. Gatera.
Yes, ma'am.
Gatera, we are going to, you will be presenting now. You're ready, right? You will be presenting on towards a framework for context aware intelligent transportation system, case of Kigali. Are you ready?
Yes, I am.
Yeah, please start. Thank you.
Welcome. So let me know if you can see my
I
screen.
can see your screen and do keep the time frame in mind as well. You have 7 to 8 minutes. Okay.
Thank you.
Thank
Thank
you.
you. I am Gatera Antoine from University of Rwanda. Somana Misheka Gurav Bajpai, they are my quarters. The quarters in this work. So, short introduction about this intelligent transportation. We use this keyword to describe the systems to improve the driving experience, which includes the intelligent cars, intelligent system that helps people to move from one area to another area. So the integration of ICT in transportation leads to intelligent transportation. So as a smart city requires intelligent transportation or smart mobility, we explored the process to achieve intelligent transportation, particularly in my country, where they define a smart city as a city where we see the power of technology and the power of data in the innovations to improve the quality of citizens, the citizen in the city. So we want to explore the process to achieve the smart city through intelligent transportation and intelligent mobility. A short background, there already is some existing framework for intelligent transportation, like in these countries, Asian, the Southern Asian nations, where they conceptualize their own intelligent transportation framework to guide each country belonging to this community to conceptualize intelligent transportation. Also, the Asian Pacific region has also started deploying some systems, although they claim the regulatory framework is challenging. Also, the European countries, through European Union, they have started implementing intelligent transportation. So we wanted to look at how our country or our region can conceptualize intelligent transportation based on IoT, Internet of Things. A short introduction to the transportation in Rwanda. It is operated in 3 modes. So the one we are talking now is land transport. And land transport keeps facing challenges such as delays in the unpredictability when it comes to transport. And also there is a lack of integrated transport. So in order to achieve effective transportation, the government of Rwanda tried to separate the policies, implementation, and regulatory responsibilities to different agencies to see how each agency can tackle its responsibility to achieve the effectiveness of transport. So these are the 4 areas. They separated the responsibility and also the policy implementation. Each layer is having the people that work on that layer. The political, for example, the Minister of Infrastructure is the one in charge. So to conceptualize an intelligent transportation system for our city, we surveyed through the government documents and also through people, particularly those who are decision makers, to see how themselves they understand, how they are read also, their opinions for achieving this intelligent transportation. So in these 220 people, these are the percentage of their education level. As I have said, our target were the professional from government and also public sector, as they are key influencers of intelligent transportation. So we explored the process to achieve intelligent transportation and also the challenges which are already there. These are our target, and these are the percentage of their sources. Some were government, private sector, public sector, and the university. And on the figure, we can see the proportions. What we found out is that those people are not context aware. They don't know exactly. At 73%, they don't know, they are not aware of intelligent transportation, which is, of course, a big challenge. And also we explored some technology in literature review, some technology in the system to view how they are aware. So these are the 10 technology or systems we selected in our literature review, and we were questioning them how much they are aware of, and these are the findings. And also we see majority they are not aware. So after seeing all those challenges, we came up with this context framework, which we came up proposing. It has three layers, by which each layers I described before it has to see which layer it can work on. As the political layer, the infrastructure layer, themselves, they can see where to tackle. For example, the input layer, there is a need of infrastructure. So the Ministry of Infrastructure has to be at that layer and see what is needed on this layer. And also the hidden layer, which is the regulatory layer also, the regulatory people can work on this to see how the transportation can be effective. So last, as a conclusion, we found out there are still challenges that need to be addressed to achieve the intelligent transportation. We aimed at seeing the perception of these people, the managers, the city managers, the transport managers, and also the process to achieve this intelligent transportation. So we found out there are a lot of challenges. Of course, with those challenges, there are opportunities for finding solution to this intelligent transportation or smart mobility. So at the overall, we found there is a need of training those people. They need real training, as they have to be aware of these systems currently out to see how they can start gradually conceptualizing intelligent transportation in our country. So these are some references we went through to see the government document and also existing framework. Thank you very much.
Thank you, Katera. Thank you so much. Sir, any questions from your side, Nilesh sir? Okay, thank you, Katera. It was a great presentation. Thank you so much.
Thank
So
you,
we'll
ma'am.
move further, our next presenter is Bonani. Yeah, Bonani. Yeah, you can start with your presentation. Yeah, your screen is visible. You can start.
Am I audible?
Yes, you're audible as well.
And can my PowerPoint be seen?
Yes.
Okay. Good afternoon, speakers and my fellow mates. Here I am to present my paper titled Internet of Things, Three-Layer Architecture, Security Issues and its Countermeasures. Introduction. The Internet of Things is a tiered framework that necessitates the use of diverse technologies for capturing, processing, analyzing, and storing large unprocessed data in the cloud-based data centers for IoTs to function in a manner desired. The security and the privacy are some of the critical concerns with increased communication among billions of IoT connected devices. In my article today, an overview of three-layered IoT architecture is provided, and the vulnerabilities and the threats in all the three layers have been discussed. It also discusses the security practices that can be enforced in each layer due to the limiting functionalities of the current hardware technologies. And the article also goes to explore some of the countermeasures and the protection methods, such as authentication, authorization, lightweight symmetric and asymmetric algorithms that can be implemented to prevent attack on three layers. So this is my IoT architecture, and it defines the connectivity, communication protocols, configuration, and the organizational structure of the network to be used by the web-enabled smart devices. The sensors protocols. So this is my diagram here showing the perception layer, network layer, and the application layer of the three-layer architecture. And the sensors protocols, actuators, cloud services, and layers all play a significant role in IoT architecture. There is no single architecture that is agreed upon. Researchers have suggested various architecture, but my paper is completely focused on the three-layer IoT architecture. So the three-layer architecture, as the first layer is the perception layer, the second is the network layer, and the topmost layer is the application layer. The perception layer is the lowest of the three-layer IoT architecture that is responsible for hosting smart things. The physical layer, the sensors in the physical layer senses certain physical parameters or detect other smart device in and around the surroundings. such as the actuators, devices, and the wireless sensors to gather information from the surrounding, information such as humidity, temperature, and so on, and convey them in digital streams. The primary function of this layer is to provide unique address identification and enable communication between low-range technologies such as RFID, NFC, Bluetooth, 6LoWPAN, and others. Now, in the network layer, which is the core layer of the conventional three-layer IoT architecture, is capable of forwarding data for specific or for application-specific services. It enables secure communications among smart things and with the cloud via the IoT gateway, wide networking technologies such as wired, Wi-Fi, and cellular technologies. This layer also ensures that each system has its unique addressing and routing capabilities, which are capable of seamless integration of infinite number of devices into a single unified network. The IETF implementation of 6LoWPAN protocol, IPv6 for unique addressing of devices, is one such work involved. The application layer, which is the topmost layer of the IoT architecture, of the three-layer IoT architecture, is responsible for providing application-specific services such as the smart education, the smart health, the smart grid, smart transportations, and many others. Now, the security issues of the three-layer architecture, and as more and more web-enabled smart gadgets join the community, greater the security breaches, and so the attacks at the aforementioned layer. Security requirements are different at different layers of the IoT architecture, and I've highlighted all the attacks at all the different layers. So going ahead, this is the threat and the vulnerabilities of the perception layer. This is the perception layer as here because, and this table is based on this attacks that are displayed here is based on technologies that are used. So it's a technology based attack. So if RFID is a technology, the different attacks that we might encounter is the DOS attack, the cloning and the spoofing, the man in the middle attack, eavesdropping and replay, and eavesdropping and replay for the RFID technology. This is the description of the different attacks that has happened in the RFID technology. So
Hello. Yeah. Okay, sir, we'll move on further. Eric is here. Eric? Eric?
Yes, I'm in.
You're here, right? Eric? You will be presenting a paper on IoT application for spruce fire detection in Raunda. Can you start with the presentation, Eric?
Yeah, thank you very much.
You're not so clear. Just speak louder.
Oh, let me increase the volume. So can you hear me?
Yes.
Yeah, thank you very much.
Please share your screen as well first.
Let me share the screen.
Yes, I can see your screen. You can start.
So can you see the full screen of it?
Yes, yes, please. You can start. You just have 7 to 8 minutes. Please keep that in mind.
Okay, thank you. I'm Eric. Those are the authors of this paper. So we wrote on IoT application for spruce fire detection. So the case study, we targeted the cases in Rwanda, but of course we are from University of Rwanda. I'm a PhD student in African Center of Excellence in Internet of Things. This is what I will be presenting. Introduction, the problem statement, related works, and then I will talk about our proposed architecture and how we configure them, and later on the result we got, conclusion and future work. So in fact, in our country, so we made a lot of assessment in real life. So we find out that there are a lot of cases of fire which result from different challenges. So the most cases of that, they are building burnt. So this is the correction of the data we collect from ministry in charge of disaster in our country. So they recorded 326 fire cases between 2010 and 2019. So all those cases, they have been result from the fire which causes those burns. And of course, when it comes to fire, two houses burning, there are a lot of damages. People can be dead, and also some materials or equipment can be abused. So there are a lot of challenges we highlighted. So most of buildings, they have equipment to fight against fire. We call them fire extinguishers. But the problem is there's a lack of training for people living in those houses or people working in those houses. So the training are not enough, like they are not enough trained. So the other cases, even though they are trained, when the fire is occurring, so people get fear and they run away instead of going to switch on those equipments. So that one is also another case I didn't highlight there. So the other concern is the detection of existence of the fire outbreak is still challenged. So detection is an issue. Knowing that the fire is going to happen, the information will be shared. There is no way to correct those information before. So that things results to delay of information sharing. So when you know the information rate, of course, the sharing those information to the people in charge, it will take time, resulting to people dying and materials being burned. So the other challenge we highlighted are alerting. So when there is a fire, like the fire is occurring and building, for example, is being burnt, so the surrounding people will be communicating to the people in charge or the fire brigade. But of course, the way of notification, they will use toll-free calls. Sometimes those numbers are busy enough in a such way that you can look for someone to contact within like 3 hours without picking the call. So that's a challenge we saw, which can also causes a lot of things like injuries and asset being damaged. So those are some highlighted points we considered, which attracted us to go ahead and propose a specific solution to automate and to automate the process without requiring a lot of users' effort. So before we go through, after finding out these problems, we go through related works just to see some challenges and some technologies they use so that we can repeat the process. So we did a lot of literature survey, but we corrected a few just for presentation. The remaining part is on the book, on the paper, sorry. So those are like 4 cases we sampled, more like, because here there's 2 cases. They are monitoring, like building monitoring, just to make sure that there are some individuals in the house. Because as long as the house is burnt, the fire brigade, they have to be aware how many people were there, so that they can fasten to save those people. So the paper number 1, which is 5 in the reference of the paper, so they talked about building monitoring using sensors technologies, but they also appended a video tool, like to know the people who are in office, so they use the video. But the problem of this is that the privacy will be exposed. So you know that when you are in the office, you can remove your chat or you can sleep when you are tired. So the privacy, the video doesn't allow privacy so we are talking about the vulnerability of those proposals versus what we proposed. So the second record is they are talking about using detecting indoor occupants of users by using wearable devices and cameras. So most of them, they used nano-intrinsic approach. So they used the existing technologies like smartphones. When you are holding a smartphone, as long as you can be connected to the internet of that base station, so they can know that there's someone around. So they use this technology, but it suffers for those who doesn't have smart tools. So when you are visiting that organization with no smartphone, you will not be counted as if you were there. And also, as long as they use cameras, that's another challenge. So point number 3, they are not counting about visitors because they don't have cards. Point number 4, they used videos to detect fire, which of course result to video processing, and that things requires computation overhead. So those are some papers we surveyed, and then we proposed an IoT technique to use sensor deployment and some actuators. Then we propose a data management so that in the future we can do kind of prediction models. And also we provide some alert notification. Then the the last one is cloud services. So those are the key points we mentioned when we are writing and implementing this paper. So the proposed architecture is looking like this. So we proposed the sensor node and actuation in a room just to detect how many people in the room using infrared proximity sensor. And then we detect the smoke by using smoke sensor. But of course, we are taking advantage of some smoke sensors which are deployed in most of buildings. So of course, like the infrastructures, we are taking advantage on, we are building on top of existing technologies in the buildings. So for notifications, we proposed alarm, buzzer, and then light emitting diodes, just to highlight if something goes wrong. So the second module is to check if the smoke is greater than, the amount of smoke is greater than the threshold. Because if someone is smoking, it doesn't mean that there is a fire there. So there are some threshold we will be detecting so that it can just provide that, it can conclude that the fire is about to happen. So the third module
Dear
is,
presenter, sorry to interrupt you, but you have last 1 minute.
so this one is just to show the flow, but the key point to mention is this architecture showing the security, the tools used, the communication protocols, the services, and application. So the next thing is to show the deployment architecture. So this one shows that the devices will be connected to the MQTT broker, and then the database data will be sent to the database, and notification will be sent back to the users. So this one is a deployment architecture. So the next thing is a sequence diagram showing how users will be communicating with the system. So this shows how records will be captured, how notification will be sent, and how the security people will come up and save the people who are trapped. So this prototype setup showing how things works at the ground and how data have been recorded. And then later on, this is the data visualization showing the amount of smoke which have been detected along the way, and at the same time, the number of occupants the infrared sensor detected, because those two things will be in conjunction so that the people in charge of fire brigade will come and know how many people to evacuate. So those are the results of our proposed system. So those are the data sets which have been generated, but this is a sample data, so we collected a lot of data. And this is our conclusion. Okay.
Okay.
Sorry, I was facing a problem of the internet. But this is our conclusion, showing how we have been implementing our objectives, and the future work shows that we will be providing the Android smartphone just to send through emails, because the SMSs are cost effective when you didn't use cloud services like Twilio. So the last one is to append advanced prediction methods so that we can predict based on the previous information or the previous data we have been capturing, and predict or forecast the future of the existence of the fire and the casualties who have been affected. So thank you very much. This is our work, and thank you for your attention.
Sir, if you have any question for presenter.
No, sir. No, sir.
Okay, thank you, sir. Thank you, presenter. And now we move forward. Our next presenter is Kaushik, and his paper title is Analysis and Forecasting of Cybercrime Incident in India. Kaushik, are you there?
Hello.
Yes, Kaushik.
Hello. Yeah. Should I start, sir?
Yes, sir.
Good afternoon, everyone. Thanks for providing an opportunity to present here. And our paper title is Analysis and Forecasting of Cybercrime Incident in India. In this work, we have tried to work on cyber security. It's basically in cyber security domain. I'm moving towards the next slide. Sir, in India, we have analyzed that there is some increase in cybercrime growth in the recent year. Okay, what is the abstract? India is gradually processing towards being a digital economy, as per the data published by the National Crime Records of Bureau (NCRB), that is owned by Government of India. They have imposed the data set. They have published the data set for last 20 years. So we have done here time series analysis has been used to forecast future trends of cybercrime attacks, and various methods of cybercrime we have analyzed, and the categories are analyzed on the basis of state basis also. Our experimental evaluation shows that our model is capable of forecasting the future trends of cybercrime incidents, and graphically we have represented the suggested future prediction and the visualization for analyzing and for raising awareness among the mitigation of attacks. Now I'm moving forward to the introduction part. India has made a significant advancement in building up a digital framework for the digital economy. If we look at in the past, in 2002, India has around 167,756 internet users, but as of 2019, India possesses around 636.73 million of internet users. And between 2015 to 2029, over 33,000 cybercrime has been recorded in India. In 2007, India ranked in comparison with the highest number of cyber attacks detected among the list of countries. India recorded 21,796 cybercrime in 2017, which is the increase of 77% from 2016. And this is the motive. Yeah. Yes, sir. And this is the motivation of our work. Cybercrime analysis, cybercrime pattern, generating user awareness so that end user will understand that the reports by the cybercrime cybercrime incidents across the India country. This paper gives a comprehensive statistical analysis of the cybercrime register and the types of cybercrime using 2017 to 2019. So I'm skipping a bit the literature survey part. I'm moving forward the statistical forecasting that we have made in this paper. So actually in this paper, we used ARIMA, average auto-regressive integrated moving average model on yearly cybercrime offenses between 2022 to 2019 in India. First, we take the stationary of time series analysis before implementing ARIMA. To predict, we have predicted the future trend of cyber attacks from 2020 to 2025 as data published by NCRB, that is Government of India, up to 2000.
Hello. Sorry from the technical issues there is. So do you have any question?
No, I don't have any question.
So move forward for our next presenter.
Yes, please proceed.
Sazia Begum Sayed, and her paper title is Empirical Analysis of Static and Dynamic Stopword Generation Approaches. Shazia is here.
Yes, sir.
You can please present your paper.
Is my screen visible?
Yes, it is. And please make it full screen. Okay.
So I'm Sazia Sayed. I'm assistant professor in S.S. Agrawal College, Navsari, and PhD scholar and working under the guidance of Dr. Preeti Sajja. My today's presentation topic for the paper is empirical analysis of static and dynamic stopword generation approaches. This is the outline of my today's presentation. I'm working in the field of natural language processing. The specified field is text summarization. Text summarization is a process where we are creating shorter version of text which will save the reading and reading efforts or reading time. One type of text summarization is extractive text summarization, and this extractive text summarization will select the summary from the given text which is based on statistical and linguistic feature. For summarization or for classification or analysis, text pre-processing is an important part. So text pre-processing is a combination of three things, that is tokenization, stemming, and stopword removal. Tokenization is a process where we are converting the paragraph into lines and lines into words. Stemming is a process where we are finding the root word for each word, like sing is a root word for singing, dance is a root word for dancing. Next task is stopword removal. So stopword removal is a process of removing stop words so that after the stopword removal, we will end up with fewer terms than before, and this will be helpful in improving the accuracy of analysis or summarization process. So first of all, what is stopword? They are the words in text that does not have any significance, value or information, but they occupy the large fraction of text. and they are used in the text for the satisfaction of grammatical syntaxes. Words like articles, pronouns, adverbs, prepositions, we will consider these words as stop words, and we are using these words for construction of language. They did not contribute towards the meaning of text. It is observed that 10 most usually used words in English normally report to 20 to 30% of words in document. So that is why it is important to eliminate stop words for further processing. These are the examples of stop words types with stop words. These are some few more stop words given. So basically, if you want to find out the stop words and remove them, we have two ways. First is a static way and the other is a dynamic way. In static way, we will pre-compile a list of stop words and in any given language, and then each word of our document will be compared or matched with the given precompiled list. If match found, we will remove that particular word from given text. Why? Because it is not contributing to the meaning of text. They are just used for the sake of grammatical structure. The second way is a dynamic way. In dynamic way, we will be not using any kind of precompiled list or corpus, but we are dynamically generating the stop words list and removing it. So for the same, we have used a Zipf's law. We have implemented Zipf's law for the dynamic generation of stop word. So Zipf's law is saying that frequency of any word which is inversely proportional to its rank in a frequency table. So if you prepare a frequency table, frequency of any word is inversely proportional to rank. Basically, it's a distribution model which predicts most relevant terms, which will give infrequent terms and relevant terms as well. This is the related work which is done in the given same area of stop word removal. I'm skipping this part as we are having only few minutes. This is the methodology or proposed algorithm for finding the stop words using static approach. In static approach, we are first reading the text. We have the pre-compiled list of stop words, and first of all, the given read text will be tokenized and stemming will be applied on it. After the process of tokenization and stemming, we will compare each word of our text with the precompiled list words. If match found, we will remove them and those words will be removed from the text. This is the static way of doing. This is a classic way of doing stop word removal. Now in dynamic approach, we have implemented a Zipf's law. As I told you that Zipf's law says that rank is inversely proportional to frequency. So first of all, we will, in dynamic approach, we will read the text, we will tokenize, apply tokenization and stemming, and then we will calculate frequency of each word in the text. After creating this frequency table, we will sort the frequency table based on frequency. And then we will remove some topmost terms and some bottommost terms from the list, and those removed terms we will be considering as stop words. So for this, we are preparing a log-log plot of rank and frequency, and based on the log-log plot of rank and frequency, if we are getting the slope which is nearer to -1, we will be removing that. If you see, this is the log-log plot of my data set. If you want the slope, we should be nearer to -1.
Dear
we
presenter,
will,
you just have 1
yes.
minute left. Kindly conclude, please.
Okay, so this is the log-log plot. These are the experimental result of dynamic approach where we it is observed in this all 5 categories are near about 52% in average, and in static approach it is 44% on average. So from this study we can conclude that dynamic approach is providing or finding out more stop words, but of course it is depends on the threshold which we are deciding for head and tail for the removal of stop words. In static approach, time will be consumed because we are comparing one and one word. In dynamic approach, the time will be saved, but there is one limitation of dynamic approach is non-stop word sometimes will also be considered as stop word, and they will also get removed if they are most frequently or they are very rare frequently occurring words are there. These are the references I have used.
Yes, thank you so much. Thank you, Sazia.
Thank you, ma'am.
Thank you. So we'll move on to the next presentation. It's Rohit.
Yes, ma'am.
You will be presenting on modeling human tendencies for password guessing.
Yes, ma'am.
Yes,
I'll share
please
this.
proceed. Yeah. Yes, your screen is visible.
Thank you, ma'am. So today I'll be presenting on our paper, Modeling Human Tendencies for Password Guessing. And this has been done with the help of my colleagues from Cheyenne Agriculture Engineering College. So moving on. Okay, so as we know, most of the security authentication mechanisms use passwords as one of the most important mechanism to authenticate a user, right? So passwords have glaring deficiencies. However, there is no sight of passwords not being used in future. So we have to ensure that the passwords that we use are going to be secure. And at the same time, to making them secure, our aim in this paper is to perform guessing attacks on such passwords. Hence, we can find out the passwords that are really weak and weed those out, right? So when we talk about password security, what is important is the number of guesses that an attacker takes to guess the password or while doing a cracking attempt. So the guessing of a password or the guess numbers that a password requires can be translated in terms of probability. How probable a password is. If it is more probable, then it is easier to crack. If it is less probable, then it is tough to crack, right? So most of the traditional systems enforce password policies that force the user to use uppercase, lowercase, and special characters, right? This brings on some password meters that we see here. So these password meters, they are based on static rules. But what we want is to see the passwords of existing users, model their password distribution, and find out the least or the most probable passwords based on the probability that we have learned, right? So there are several guessing methods when we are trying to study passwords, right? So first two are John the Ripper and Hashcat, right? So these two password guessing methods use a combination of what I call a dictionary word plus root. So the word could be a natural language word or a dictionary word. So the simplest rule is to use the password from the word and then append 2 digits. So you get password 11 or password 12 and so on. So next is Markov models. Markov models are a statistical method to guess the next following character in a particular sequence given the frequency of the preceding characters. Okay, and then the next and the last is PCFG. So this introduces a grammar where we get template structures such as L8D2, which correspond to 8 letters followed by 2 digits. If we substitute the terminal structures such as the letters and the digits into the pre-terminal structures that are the template structures, we get password 12 and password 11 and so on and so forth, right? So these are the methods that we have seen previously. So if you want to model the real password distribution quickly and start guessing the passwords, there's only one such viable technique, and those are neural networks. Okay, so our implementation consists of only lowercase characters, right? Because in order to not strain the network, we use only lowercase characters and the numerals. If we have to strain the network, then the prediction problem becomes quite tough, right? But in order to guess guess the passwords that have uppercase letters as well as the special characters, what we can do is we can calculate the relative frequency of uppercase and lowercase characters. And then while we are sampling and generating the last list of passwords, what we can do is use this distribution as a sampling distribution and then sample the case of each character. And once you have got such uppercase passwords, passwords that are containing uppercase, then you can use the leet speak conversion from hashcat to convert them into passwords having special characters also. Now, the model architecture. So we experimented with a number of various parameters, and we have finalized down it to 2 different networks. So each network is going to be a 3 stacked bidirectional RNN layers network, and each of those is going to have 2 different blocks. So first is going to be LSTM block, and second is going to be GRU block, right? So this is going to be trained on the Keras framework with the TensorFlow backend. Now, the dataset is going to be RawQ, which is a list of leaked passwords from the RawQ leak that happened years ago. And in order to prepare this data set, what we thought was selecting all the passwords that are less than or that were in length less than or equal to 32, which amounted to about 14 million passwords. So as a basic pre-processing step, what we did was we removed all Unicode and ASCII control characters. And then we split the passwords data set into training and testing set, right? So the training set consisted of 70% of the data set with 9.9 million passwords. And in order to not let the network be evaluated on the passwords that it has already seen in the training set, what we do is we perform a set difference operation with the remaining 30% of the data set and the training set, so as to eliminate all the passwords that could be repeated in the training set from the training set in the testing set. Okay, so we get total of 3.9 million unique passwords. So after training, how do we sample these passwords, right? So each password, if you want to sample or guess a new password, what we do is we start with a start character. This is usually \T, which is the tab character. We have selected tab character as our start character. Then the next character, then the network outputs a probability distribution over the next character in the sequence, right? So if we will select all the characters that have the probability which is greater than the threshold that we have selected, and we continue this operation. If the next character selected was the end character, which is we selected as new line character, and if the probability was still greater than the threshold, then we sampled the password and broke the while loop. Okay. So this is the process for a single password generation. We start with the initial state of the neural network and then the start character that you see on the bottom. So this is going to be \T, and the network outputs probability distribution over all characters in the sequence. Now we select the character with the highest probability, which corresponds to P here. And then we'll select this as a context for the next calculation of the neural network. And then we'll select it as a context, we'll feed in the state information, and then we'll get the probability distribution of the next character in the sequence again. So we'll do this procedure until the network at the end selects the end character. If it selects the end character, then it has chosen that the password that it is constructing currently is going to end right now. So we'll stop the sampling process for that particular password there. Now, if we are going to multiply probability, which are numbers that are less than 1, continuously, then it is going to be very difficult to set a threshold. The threshold will be really low. So in order to, and this has an undesirable effect where the network prefers short passwords. So to counter this, what we do is length normalization. It is basically is incentivizing the network to generate longer passwords. So this is done via 2 parameters, which is the normalization constant. This particular parameter in the normalization controls what or how much importance is given to the length at any
presenter. Sorry to interrupt you, but you have last 1 minute.
Okay. And then the threshold is going to be the threshold above which, if the password is scored, then it is going to be sampled. Okay, so visualizing the sample process, we start with the start character and we sample the letters. If it is the score is less than threshold, we will not select the password. If it is greater than the threshold, then we will select the password. Okay, so these are some of the passwords that did not match with the testing set that our network generated. As you can see, the model has learned to correctly guess dates, email addresses, and so on. So now the cracking performance. For 1 to 8 character performance, both the networks racked up to 50% of the passwords that were matched with the testing set. For 9 to 15 characters, we get a bit less, up to 30% cracking performance. There's a severe lack of 16 to 32 character passwords in the dataset, and this can be reflected in the results also. Here, our guess is that the flexibility of the LSTM network helps in improving the percentage of the passwords guessed with respect to GRU. Now, if you see the cumulative password cracking process, you can see that GRU model is on top for less than 8 and less than 15 character passwords. But for greater than 16, we believe that the LSTM's flexibility with the third gate helps it in cracking the higher length passwords. Now, conclusion is that we can safely say that the neural networks can model the human password generation process. We have seen password generated such as love forever, and love forever, right? So they have captured the human password generation process very effectively. And the passwords also that did not match the testing set also looked that like they were generated by humans. That was also good. So if you are attacking using the password that are generated by the neural networks, you can also augment the list of the password generated by the neural network by concatenation and mangling rules that we had seen with tools such as Hascat and JTI, right? And also, if you want, using such techniques, we can model the strength of the password based on the password that we have seen that are real and not just some static rules, and also mount effective attacks for password guessing. Thank you. Any questions?
Thank you. Thank you, Rohit. Thank you. It was a good presentation. Yeah. Thank you. So we have come to an end. Thank you, everyone. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. So kindly cooperate with the team of ICT4SD 2021. I also thank our session chair, Nilesh Modi, sir. Thank you for chairing the session. It was great to have you at this session. Just a minute. A token of appreciation from our side, sir. Thank you so much. And thank you, everyone. And I just kindly request.
Hello, Richa.
Yes, sir.
Yeah, there is a correction.
Yes, sir. Tell, sir.
There is a correction in the certificate. You just check out the things. Name.
Oh.
The name is wrong, or you might have shared a different certificate.
Okay, sir.
I'm
I'll check.
Nilesh Modi.
Okay, sir. Sure, sir. I'll just. Thank you. So I request all to just on their cameras for a quick snapshot. Thank you. Thank you, everyone. Thank you. Just a minute. I'll do that again. Can you please on your cameras, please? Thank you. Thank you, everyone. It was great to have you here. Thank you, everyone.